Hi, Assalamualaikum and good day. Today you are going to learn on how to find product of three vectors. This is the objective of today's lesson. Hopefully, by the end of this session, you are able to perform product of three vectors, namely triple scalar product and triple vector product, and able to explain the difference between these two products. There are two types of product of three vectors, namely triple scalar product and triple vector product. Consider three vectors A, B, and C. The triple scalar product is denoted by A dot in bracket B cross C or A cross B then dot with C, and it possesses a scalar quantity or a value. The triple vector product is denoted by A cross in bracket B cross C or A cross B then cross with C, and it possesses a vector quantity. Take note that for triple scalar product, the cross must always be inside the bracket. If the dot product is inside the bracket, the answer is undefined as a vector cannot be crossed by a scalar. Solving the cross product inside the bracket, you should obtain a vector. When a vector dot with a vector, it becomes a scalar, as this is referred to scalar product. For triple scalar product, the order of the vectors is not important. As long as the cross product is inside the bracket, you should get the same value. Conversely, order of vectors is important for triple vector product. Take note that A cross in bracket B cross C is not equal to A cross B then cross with C. You should get different vector for each of them. There are two methods that can be used to evaluate the triple scalar product. The first method is by obtaining the answer for the cross product first, then find the answer for the scalar product. The second method is by solving the determinant of order 3, in which the component of the first vector is in the first row, the component of the second vector is in the second row, and the component of the third vector is in the third row. As for triple vector product, there are also two methods that can be used to evaluate this product. The first method is by applying the determinant twice, that is, evaluating the cross product inside the bracket first. The second method is by applying the following formula. The triple vector product A cross in bracket B cross C or A cross B then cross with C are usually not equal, and it can be calculated easily by using the formula. Refer to example 11. Given three vectors A, B, and C, you need to calculate the following product of three vectors. To evaluate A, which is referred to the triple scalar product, you may find A cross B first using determinant, and you should obtain a vector negative 10i minus j plus 4k. Then, find the scalar product between the vector that you have obtained with vector C and simplify, you will obtain negative 49 as the final answer. Another way to evaluate the triple scalar product is by solving the determinant of order 3, in which the component of vector A is in the first row, the component of vector B in the second row, and the component of vector C in the third row. You should be able to get the same answer. To evaluate B, which is referred to the triple vector product, you may find the vector product inside the bracket first, that is A cross B, using determinant, and you should obtain a vector negative 10i minus j plus 4k. Then, Find the next vector product between the vector that you have obtained with vector C using the determinant once again. Simplify, you should obtain a vector as well as the answer, that is 4i plus 20j plus 15k. Next, to evaluate C, which is also referred to the triple vector product, you may find B cross C first, and you should obtain I plus 5j minus 20k. Then, find the next vector product using the determinants once again. Simplify, you should obtain negative 55i plus 23j plus 3k as the final answer. You may also evaluate the triple vector product using the formula. To evaluate B, you need to find the scalar product A dot C and B cross C first. Then, multiply the answer, which is referred to a value, with the corresponding vectors. Simplify, you should get the same vector as obtained in the first method. Same goes to C. Three vectors A, B, and C are said to be linearly dependent, or in other words coplanar, if and only if the triple scalar product equal to 0. That is, A cross B then dot with C equal to 0. Refer to example 12. You need to determine whether the given three vectors are linearly dependent. To answer this question, you need to evaluate the triple scalar product using determinant of order 3, in which the component of the first vector is in the first row, the component of the second vector is in the second row, and the component of the third vector is in the third row. You should be able to get 27 as the final answer. As the answer is not equal to 0, we can conclude that the vectors are linearly independent. Triple scalar product can also be used to find a volume of a parallelepiped spanned by the three vectors A, B, and C. Refer to example 13. You need to find the volume of the parallelepiped spanned by the three vectors A, B, and C. Volume of the parallelepiped is defined by the modulus of the triple scalar product. As the answer for the triple scalar product is equal to 4, the volume is equal to 4 units cubed. If let's say the answer for the triple scalar product is a negative value, modulus the answer, you should obtain a positive value. Bear in mind that the answer for the volume is always positive. In order to get better understanding on vectors that you have learned so far, please do the following exercise. In the next lesson, you are going to learn about the application of vector algebra, that is on how to find the equation of line, the equation of plane, and the intersection point.